Alright, today's topic is we're going to be continuing the discussion of rules of exponents, and we're actually going to be looking at part 2 today. So if you didn't do part 1, you need to make sure you do part 2 first, and make sure that we have all these together. Now with our objective today, it's going to continue to be the same thing, but we're going to add, subtract, and multiply polynomials to create examples to support some reasoning that we might have as we continue forward. But the idea is we're just going to learn our property of exponents and be able to use those appropriately. So the first one is kind of an extension of our product rule and an extension of our power of a product. And so now what we have is we call this rule a power of a power, in which we already have an exponent on the inside of the parentheses, and then we have an exponent on the outside of the parentheses. So if we look at the algebra side first, it says when raising a power, the base, to a power, multiply the exponents that you have. And so when we look at a situation like this, we have a to the 20th to the 6th power. And so in a sense, what we can look at is that this is a to the 20th times 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 a to the 20th. And you get the idea as I just continue to multiply this 6 times out. Now the way that I would do this, as I told you from your product rule, is that then now you would just start to add all those together. Well, we know that repeated addition of the same thing over and over and over again is just multiplication. And so whenever we have this power to a power, we're just going to simply multiply the exponents. And so this becomes a to the 20th times 6, which would give us a to the 120. And so the idea there is that we're just taking this, and if it already has an exponent, then we're just going to multiply it. So this is still distributing or kind of sharing that exponent to everything, but if it already has something in place, then we're just going to multiply it out. So let's look at some other numbers here. So we have 2 to the 3rd to the 4th power, which would give me 2 to the 3 times 4, which would end up giving me 2 to the 12th. And then here, the same kind of idea, 5 to the 6 times 2, which would also give me 5 to the 12th. So the idea there is that when we have a power to a power, we're just going to multiply the exponents together. Now what I'm going to show you is some of the examples that we had looked at, but we didn't necessarily know that we could do it this way. And so the idea here is that we have multiplication and then we have our division on the other example. And so the idea of what we did before is that if we think of this as our product of a power, then, or the power of a product, we would take this 4 that we have out in front, so we would take this 4 exponent and we would kind of share it or raise each one of these to a power. Now the way that this would work is that this would be 3 to the 2nd to the power of 4 times x to the 3rd to the power of 4 and times y to the 5th to the power of 4. But the idea is we can kind of shorthand that a little bit, and we can see that what we're going to end up doing is we're going to use the rule that we just put in place, and we would multiply those. So if I wanted to shorthand this, I could take 3, and I already have an exponent of 2, and so I have an exponent of 4 out here. I'm just going to multiply them together, so I get 3 to the 8th, times x is my next thing, and so I have 3 to the 3rd to the 4th, which would give me 12. And then times y to the 20th. Now if you look at this example above it here, you can kind of see where those things are coming from. So this is 3 to the 2nd to the 4th, which I just told you to multiply those two things together, and multiply those two things together, and multiply those two things together, and I get 8, 12, and 20. So the whole idea is that we're sharing, the exponent, but if it already has something in place, we're just going to multiply it. So let's look at the next example. So the same idea happens, is that I need to take this exponent of 2 and share it to each thing here. So I'm sharing it to the 3, sharing it to the y to the 3rd, sharing it to the 2, and sharing it to the x to the 5th. So when I do that, 3 doesn't have anything, so it's just going to be 3 to the 2nd. The y already has an exponent, so it's going to be y, and then I'm going to multiply those together, so 3 times 2, which is 6. Divided by 2 to the 2nd, because that doesn't have an exponent, and then x to the 10th, because I already have a 5 exponent, multiply it by the 2, and that gives us 10. And so there is our simplified answer there. So the whole idea there is that if it has something, we just multiply the two exponents together. If it doesn't, then we just apply the exponent. Now these last couple rules are pretty straightforward to follow, and so the next one we have is the zero exponent rule. And basically what happens is we can kind of take all our rules and kind of jumble them up into one big thing, but the idea is that anytime we raise something to the power of 0, it's going to equal 1. And there's really no way around it, so 2 to the 0 power is 1. 5 to the 6 power to the 0 power still results in 1. Now if I was to use my power of a power rule that I just learned, I would multiply those two exponents together and I would get 5 to the 0 power, which would give me 1. Same idea when we look at the algebra side of it. Even with variables, that same rule is in place. So I'm basically taking everything that's inside of here and raising it to the power of 0, which would give me 1. Now if I wanted to look at the rule of that, I would distribute my exponent of 0, be x to the 0, y to the 0. Both of those would equal 1. 1 times 1 is 1. So the whole idea there is that anything to the power of 0 we can just kind of scratch and make it a 1. And that's really how our zero exponent rule works. Now the last thing that we're going to look at is negative exponents. And I told you before that negative exponents are okay, but they just need to be written a little bit differently. Negative exponents are considered to be not simplified. So when I look at negative exponents, I don't really ever want negative exponents. And so whenever I use negative exponents, I want to get rid of them. And so there's a way that we can do that. So when I raise a base to a negative exponent, so if we're looking at the algebra side, when raising a base to a negative exponent, take the reciprocal to that exponent. Now remember the whole idea of a reciprocal is to kind of flip a fraction. And so the idea here is that I don't necessarily have too much to work with, but the idea is I can take a to the negative 1, make it a fraction, and then take the reciprocal of that. And that's going to give me 1 over a. But when I take that reciprocal, that exponent turns from negative to positive. And so then I would have 1 over a to the positive 1. So the idea that this negative exponent really just means reciprocal. So as soon as I'm done taking the reciprocal, I can get rid of the negative exponent. And so let's see how that works with some of our examples here. So if we follow some of the rules that we already have in place, this would be 2 to the power of negative 12. So I'm still following the same process regardless of the fact whether these are negative or not. So in a lot of these problems we're going to continue with negative exponents right up until the very end, and then we're going to take care of them. So I have 2 to the negative 12. So I'm going to take the reciprocal of this, which would be 1 over 2, but I'm going to raise it to that particular exponent. So this would be 2 to the positive 12. So after I take that reciprocal is when I make it positive. I don't just take 2 to the negative 12 and make it 2 to the 12. You have to take the reciprocal. And if I look at this next example, same thing. Let's just multiply this out. So it would be 5 to the negative 12, because I'm going to multiply these two exponents together based on my power of a power. And that's going to give me 1 over 5 to the 12th. And so that's a little bit of how we use the negative exponents, and let's take a look at some more examples of this. So the idea here is that now we have some other examples, and so some things can be positive, some things are going to be negative, so we can look at how that works. So here, now we have 1 over a to the negative 2. So this works in another way too as well, and so what I'm going to do is I'm still going to take the reciprocal of this. So the reciprocal of 1 over a to the negative 2 is a over 1, because I'm just taking that fraction and flipping it, and then raising it to the power of 2. So my answer to this one is a to the second. So in some cases, it's not just going from the numerator to the denominator. Sometimes we can go from the denominator to the numerator. Now let's look at the next example. I have a to the positive 2 and I have b to the negative 2. Now another way that I can look at this is I can just make this a fraction. And I'm either going to move things up to the first floor or down to the basement. I like to use the example of just moving things that are negative. We want to make them positive again. And so what I'm basically going to do is you can take the idea of a reciprocal, but what we can do is we can separate these two pieces apart from each other. So a squared times b to the negative 2. This one stays the same since it's positive. This one needs to change because it's negative. So this is a to the second times take the reciprocal, 1 over b, and then raise it to that power, positive 2. And then I could join those back together, a squared divided by b squared. So the idea is that I can split those apart just like I did before. Now another way that I could approach this is, I can move them up or down. So if you notice, what we did is that these variables either move from the bottom to the top, or they move from the top down to the denominator. And so another way I could look at this is negative. So since this is negative, it's going to move down. And since this is negative, it's going to move up, because if we think of the reciprocal, they're basically just changing places. And so in some cases, instead of going through the whole idea of the reciprocal, I can just move something from the denominator up to the numerator, or from the numerator down to the denominator. So this a to the negative 3 is going to go down, and this b to the negative 4th is going to move up. They're basically going to trade places. And so this would be b to the positive 4 over a to the positive 3. So if you notice the difference between those two things, we basically took them, flipped them upside down, and made them positive. Okay, so now we're going to continue adding to our list here. So we had our first four, so we had our product rule, our quotient rule, our power of a product, and our power of a quotient. And so now we're going to do power to a power. So the idea of here is that we have a to the x to the y would give us a to the x times y, and so that would be our power of a power rule. Our 0 exponent would be a to the 0, or any base to the 0 is going to equal 1, and our negative exponents is simply a to the negative 1 is 1 over a. So the idea is that we have our 7 rules now, that we can take these and we're going to combine them all together so that we can make sure that we have all of our rules in play, and that we can use these things to simplify any expression that we're given. So that's going to be it for our exponent rules. So just make sure that you have all of these rules down so that we can look back at them whenever we need to.